Hello, everyone. I'm Ling from Huawei Global Training Center. Today, we are going to introduce the in-memory distributed computing engine, Spark.
This course describes the basic concepts of Spark. Before we learn the Spark, let's have a look at the objectives of our course. We hope that after this course, you could be able to understand the application scenarios and master the highlights of the Spark. Secondly, you could be able to master the computing capability and technical framework of Spark. Last but not least, we hope you could be able to master the integration of Spark components in MRS. Firstly, let's see what Spark is. Apache Spark is a lightning-fast unified analytics engine for big data and machine learning. It was originally developed at UC Berkeley in 2009. It can combine the big data with machine learning to solve the practical problems, and I will introduce it later. In essence, Spark is a fast, versatile, and scalable in-memory big data computing engine. We can highlight these four words. The versatile and scalable big data computing engine may remind you of the MapReduce, which is a calculating engine as well. So, the versatile and scalable can be seen as the common feature of the big data computing engine. But Spark is different from the MapReduce. Spark is an in-memory computing engine, where MapReduce stores the intermediate data into disk, which means Spark is much faster than MapReduce. Besides, as we mentioned before, Apache Spark is a one-stop solution that integrates batch processing, real-time, stream processing, interactive query, graph computing, and machine learning. These powerful functions help Spark satisfy the different needs in different scenarios. Let's review the features of Spark. Really fast, versatile, and scalable. The most importantly, it's a kind of in-memory computing engine. Let's explore the application scenarios of Spark. Spark can support batch processing, which can be used for extracting, transforming, and loading ETL. These three steps can be seen as the important parts of data preprocessing. By doing this, we can improve the efficiency of data analysis. The machine learning module also can solve the classification problem. For example, it can automatically determine whether the comments of Taobao customers are positive or negative. Actually, it's a typical binary classification problem. The logistic regression model and the Bayesian algorithm in Spark can solve these kinds of problems. Since most of machine learning algorithms generate optimal model by doing the several loops, it really matches the features of Spark, because it computes in memory. In a word, you will benefit a lot from Spark when you need to frequently perform some operations or when the volume of required data is large, because the data is already in memory. What's more, the interactive analysis in Spark can be used to query the Hive data warehouse, which is used to analyze the data. And we have learned it before. Stream processing can be used for real-time business such as page-click, stream analysis, recommendation systems, and public opinion analysis. Well, do you know what the public opinion analysis is? It means that monitors, analyzes, and processes sensitive and hot internet information. Then, what are the highlights of Spark? Actually, we have already introduced a lot. This slide shows us 4 keywords of Spark: light, fast, flexible, and smart. We say Spark is light because its core code has only 30,000 lines. Do you know what the programming language is used to program Spark? It's not programmed via Java, but via Scala instead. Both languages have the same styles, but in general, Scala is much simpler than Java. Besides, Scala uses infrastructure of Hadoop and Mesos, which is also an open source framework to manage computer clusters. And for fast, we have explained that Spark is memory-based, and computation in memory is much faster than that in disks. Here we can see Spark has sub-second level latency for small datasets. Actually, Spark has higher speed compared with MapReduce or Hive for large datasets application as well, such as iterative machine learning and hard query or graph computing. The third highlight is flexible. Spark provides a flexibility in different levels. For example, Spark supports new data operators, different data sources, and many programming interfaces, includes JDBC, Scala, Python, and R. But C is not supported, okay? And besides, written in Scala, Spark allows new computation operators being implemented. Simply speaking, an operator can be seen as a well-defined function. And because Scala is a functional programming language, whenever we need a new operator, just write a new function. We will introduce its built-in operators slightly later. Basically, there are two types, transformation operator and action operators. In each type, there are loads of operators, while in MapReduce, there are just two, map and reduce. That is why Spark is more flexible than MapReduce. The last highlight is smart. Spark smartly uses existing big data components, including using Hadoop as its ecosystem, without introducing something new. Thus, we don't have to learn from very beginning. At this part, we will compare MapReduce with Spark. Do you remember the steps of MapReduce? Map and reduce. We can find the output of map process written into disks and ready to be input of reduce process. The intermediate data are all stored into disk. And the procedure of MapReduce is read and written again and again, which costs a lot of time. By contrast, Spark computes in memory. The output of the last loop can be directly used in next step. To some extent, the performance of Spark is 100 times higher than that of MapReduce in terms of in-memory computing. Except few steps of data dealing, there are no difference between their performances. Let's see the results of a test. To evaluate these improvements, we decide to participate in Salt benchmark. With help from Amazon Web Services, we participated in Daytona Gray category, an industry benchmark on how fast a system can sort 100 TB of data, 1 trillion records. Although our entry is still under review, we are eager to share with you our submission. The previous world record was 72 minutes, set by Yahoo using a Hadoop MapReduce cluster of 2,100 nodes. Using Spark on 2,006 nodes, we completed the benchmark in 23 minutes. This means that Spark sorted the same data 3 times faster with 10 times fewer machines. All the sorting took place on disk, HDFS, without using Spark's in-memory cache. Additionally, where no official petabyte sort computation exists, we pushed Spark further to sort 1 PB of data, 10 trillion records, on 190 machines within 4 hours. This PB time beats previously reported results based on Hadoop MapReduce in 2009. To the best of our knowledge, this is the first petabyte scale sort ever done in a public cloud.
In the first section, we learned the basic definition of Spark and compare it with MapReduce. Then, we are going to learn the data structure of it.